So the main way to approach this problem is to work out each of these 8 terms individually using your knowledge of the unit circle and then adding them together. The first 2 work out to a half, the next 2 work out to a negative radical 3 over 2, the next 2 terms work out to 1, and the last 2 terms work out to radical 2 over 2. Fair enough. One thing worth noting, though, in this problem, because there's something to be learned in this problem besides actually just the computation of it, is that these are both cosines of opposite arcs, as are these, and these. And one thing that's hinted at in this problem is that if you take the cosine of opposite arcs, you get the same answer. This is often represented by the identity cosine of arc equals cosine of -1 times that arc. You didn't need to know that for the problem, but it was sort of the subtext of the problem for you to have that realization, so I thought I'd explicitly point that out to you. Anyways, taking these 8 values, whether you realize that or not, taking these 8 values and adding them up leads us to our final answer, and we're done with the problem. If you've forgotten or it's been a while since you've added radical terms together, I'll show you one little mini piece of this. Look at the 2 negative radical 3 over 2 terms. When we combine those, since we have a common denominator, we combine the numerators. And then since 2 divided by 2 is 1, this simplifies to negative radical 3. That doesn't explain every minor detail of the addition, but it shows you the general idea of how the radicals got added together. And that completes the problem.